in the neighborhood of 250, plus a multitude of staff and service groups. There are 98 heavy production machine tools in operation. Number 2 Shop serves a dual function in the Bethlehem organization. Firstly, it is the producer of major commercial product lines for power generating, the military, and a variety of heavy industries. Secondly, we serve as a major maintenance facility both for the Bethlehem plant and other plants throughout the organization. A proper mix of these activities provides an income for the company while assuring continued operation of other profitable facilities. Since you have not had the opportunity to view the shop and its people and machinery in operation, we are going to show you some of the normal activities occurring here 7 days a week, 24 hours a day. Our major commercial or saleable products are cast or melted in the plant electric furnaces. From here they are shipped to the press forge, where they are shaped into basic configurations prior to machining. Major maintenance work is sent to Number 2 Shop directly from the facility where it is used. Generally, for both product lines, the first operation in Number 2 Machine Shop is layout. It is here that the pieces are checked to ensure that they are dimensionally acceptable and laid out in preparation for machining. You are looking at an assortment of workpieces on the west end layout plate. The employees are landing and setting in preparation for laying out the workpiece. The workpieces you see coming into view are a variety of maintenance products that we do for the Sauk and Mills organization. We manufacture these both from new and also bring them back for repairs. The large irregularly shaped piece, now coming into view, typifies our turbine products as we receive them from the press forge. After layout, many of the parts go into the machines, such as you're seeing here. This is a large forging that is now being finished in one of the Route 3 lathes. You are watching the end being faced to length. We are now viewing one of the newer machines in Route 2. This is the largest of our saws. It was manufactured by Hem Corporation and can cut pieces up to 40 inches in diameter at extremely fast rates. The fluid that you see pouring down the side is a combination of oil and water that cools the saw blade while also carrying the chips away down into a collection reservoir. What you are looking at here is a rather unique application of boring. This is called block bitting. The product in the machine is a large shaft for tipping. We are enlarging the hole in order to lighten the weight of the shaft. The machine that's in is quite old. It dates back into about 1920. This gentleman is the operator of that machine, Tom Catcher. He's showing a little bit of shop spirit with his number 2 machine shop baseball shirt. Here you can get an idea of what it takes to be a crane man in number 2 machine shop. This is one of the low-run cranes in Route 3 transporting a workpiece down shop towards the crossover buggies, which you've already seen. In addition to the large machinery that you see placed throughout the shop, we have a multitude of smaller mobile equipment units carrying the smaller workpieces. Here you're witnessing the boring operation on what is called a reduction shaft. This also is occurring in a Route 3 lathe. What this gentleman is doing is removing the chips that are being produced inside that bore as it's being enlarged. A few minutes ago I commented on a piece of machinery that dated back to the early 1900s. This unit is one of our more modern and state-of-the-art turning lathes. It is a 40-inch American computer numerically controlled unit. The basic operation of the machine is controlled by a punched tape that is produced through a computer-assisted programming system. In order to be an operator for these machines, you must first be skilled with a conventional machine and then acquire all the technology and state-of-the-art understandings that it takes to handle that panel. In addition to this unit, we have a 60-inch CNC lathe, a 74-inch NC lathe, and most recently a 12-foot, 4-axis CNC vertical boring mill. These units can cost as much as $4 million installed. The actual operation that you're observing is the internal threading of a large nut for the socket mills. When we talk about plant and corporate maintenance, we're talking about repairing parts for our various facilities. You are now looking at an area of the erection floor with a burner disassembling some of the old parts that have to be rebuilt. After and during disassembly, all parts have to be cleaned and prepared for the remanufacturing process. This process could entail welding and or remachining, or possibly manufacture of new components. One thing that is continuous in number 2 machine shop is the need for crane service. You're observing 2 of our chainmen hooking up a job that will then be carried down shop by the overhead cranes. In the background you can see a large roll sleeve which we manufacture for Burns Harbor, suspended from one of our high-run cranes. This job will be taken down shop to the flopping and stood on end in preparation for putting on a vertical boring mill. We have now moved east to the east end layout plate. Here you are looking at a large casting that is being laid out prior to machining. The white on the pieces is actually plain old-fashioned whitewash. By putting this over the metal, it makes it possible for the layout men to paint or draw lines showing what the final configuration of the workpiece shall look like. We are now back on the erection floor in the welding booth area. What you are seeing is a welder moving a piece into position for welding using an overhead pendant-controlled crane. We have a number of these units presently in use in the shop. Now you are witnessing the action up. We have now moved to the third floor, which is in itself a small machine shop. When we talk about small, by industry standards, it ranks as a large facility. Here you are watching a slotting operation on a repair product for the mills. In this third floor shop, 39 manufacturing units. In addition to making products, both for the mills and for the commercial market, they're also responsible for the manufacture of much of the tooling used down on the first floor. You are looking at a third floor milling machine being prepared for the machining operation. Here we're looking at a third type of lathe. We've discussed large conventional lathes. We've seen a numerically controlled unit. Here we are seeing one of the third floor turret lathes. This is used to manufacture smaller parts, often repetitive pieces. The smoke that you see coming up from the workpiece is not a result of a fire. That is simply the result of the heat generated during the cutting process. Here you are watching a skilled machinist manually generating a contour that normally could be done on a numerically controlled machine. Up until recently, this is the way all contours were manufactured on our workpieces. One of the smaller conventional lathes in the third floor, manufacturing a spacer or ring. And here you are watching one of the shafts that has been manufactured on the various machines on the floor, receiving the final drill holes that are required for lubrication. Number 2 Machine Shop is dedicated to providing a quality product while assuring the safety and well-being of its employees. Our products are found in every major electrical generating facility in the United States. Our shafting and nuclear components power most of our nation's submarines, destroyers, and aircraft carriers, while our miscellaneous products assure the continued operation of many of our nation's major industries. All of us can say with pride, we work in Number 2 Machine Shop, number 1 in quality.
Jill Sipe has the story.
10 area vocational technical schools came together today to compete in the District 1 competition that has been called the Vocational Olympics. This year, Carbon County is hosting the event that only comes to our area once every 10 years.
First time in quite a while we are now the home turf, as we call it, for the competition. and they rotate every year in District 1 to all the other schools. We have a total of 10 schools here, and it's our turn this year.
Hundreds of students are involved in the competition that has over 40 events, everything ranging from welding to culinary arts. These students were chosen for the competition by their instructors at their home schools. Each competitor is also a member of VICA. What does VICA stand for?
Vocational Industrial Clubs of America. It's all over the nation.
The competition is stiff and stressful for most of the students. Each event has its own set of rules and is timed, with the judges watching closely.
Right where we are at now, it is running very close, yes. Yeah. And the boys, and the students, I should say, are look very proficient. There's always a pressure when you must go into, some of these boys are in a strange shop, I assume. You're going into a strange shop. The machinery is supposed to be familiar to them, which all machinery is standardized. But to go in there and do something like this is not easy.
The winners of today's competition will either receive a silver or gold medal. Those who win the gold medals will go on to state. And if they win a gold medal at states, they will go on to nationals.
And what would it mean if you won a gold medal? What would that mean to you?
A lot. It would be a good memory to at least go with. It's a lot to practice for. It took us like 3 months to practice for today.
And on behalf of iWatch News 13, congratulations to those who won medals, and good luck in your next competition to those who won the gold. This is Jill Swipe reporting for iWatch News.
Students at Panther Valley High School were treated to a musical concert.
And we're doing cast iron butterfly stools. I just came out here on midnight. My buddy has me all set up here, ready to go. And a little later on I'll run this, so you can see this is how we do this. This is the pendant over here. I don't know if you can see it. There's the lower head. That's the horizontal head. That's the vertical head. Used to be 2 of them. One broke down, never fixed it. Down on the other side is a head that we hardly ever use. That's the right hand. I guess that would be the left hand vertical head. The other end of the table. Over there is a air sucker. The vacuum cast iron dust. Across the way is the layout plate, what's left of it. Not much work on it. One job there. Another job there. Over there is the table where the guys sit. Eat cabinets. One with the name Buss on, I don't know who that would be. The layout plate. Cabinets, toolboxes. And this is the kitchen. Believe it or not. A well-equipped kitchen. Refrigerator. area here between the layout plate and the horizontals up above once housed several machines, CNC lathes, and roughing lathes on the other route over there. This is what's left of our work. A couple of odd pieces here. Pretty well of much of a blank area here. This is the slaughter. I don't know what they intend to do with this machine. It still works good. I guess nobody wants it. Cabinet. The honer in the process of being dismantled. This is the shower room. Welfare room. Baskets where they hang up their clothes. A junk pile up in the old vertical section. At least there's something here. Most of the area between here and the crossover is pretty well emptied up. This is the last vertical that's doing anything. Well, it's even here. Still running. Not tonight. Cutting a cast iron stool. A 75-ton crane, the only big one left. The 90 was ripped down. It's sold. This will run later on, maybe I can get it running, but first I have to get my work done, so I needed it. This is 55 horizontal. No plans for this one. This is a table model. Head goes all the way up there. And some of the jobs we did, we had to put it up. Quite a few jobs left. That's a floor model. This is a table. Probably on the floor. Installed. Across from me. '67 machine mounted in a pit, which means the head comes down a little. Also goes up high. Also has a table mounted on it. There's the job that we were doing on the finger saw, drilling holes on it here. Up to the main crossover. There's machinery all the way up to the crossover. Then all the way up to the heats. All the machinery's gone.
263 machine in the number 2 machine shop. Machinist Gene Kennedy. What he's doing, he's in the process of doing, is a drilling and tapping operation. The job we have here is a roof lift ram. The holes are a 2B fit. They're 1.5 inch diameter, 6 threads per inch. The first thing Gene's gonna do is to put his adapter into the spindle. Now this machine has a quick draw bolt. All he has to do is put it in, but what he did, it's not on the film here, you can see the yellow mark he has on his adapter. He match marks so that he uses, and he has all his run out that might be in the adapter in the same direction. He's putting his drill in and matching it to the match marks. Using his pendant station, he's now going to move on to the next hole, using the drill as a rough reference. He will then put a pointer on the end of the drill, and using his slow jog feed that he has on this machine, will position exactly to the layout and exactly to the hole location. Drill size, he checked his drawing. In this case, it called for a 1 11/32 drill. If the drill size was not given on a drawing, you can go to the chart at the tool crib and check 1.5 inch thread, 1.5 inch tap, 6 threads per inch to find out what drill size is required. This is one of the most important parts of tapping, is getting the correct drill. And after he has this located, what you're going to see him do is drill, but he will only drill in approximately 1/4 inch depth. He will then check his size to see if his drill is drilling the correct diameter. Required to be very precise. He wants his drill to to follow very accurately, so you'll start the hole with a center drill. Drill back in, match marking the marks. We'll then drill 1/4 inch deep and check the size that his drill is drilling. It is required and necessary that we do a test piece first. In other words, we'll take a piece of stock of the same material and drill and tap the test holes in a test piece prior to machining it on the job. In many cases, this is done when we are using what is known as our geometric taps. Checked it with a scale first. Now he's going to go a little bit deeper so that he can get his telescopic mic, or in some cases you might use an inside caliper. He will go in and telescopic it and then use his outside micrometer to check his drill size. To this drilling, Gene informed me that the drill did have to be changed. I mentioned that the drill size required was 1 in 11/32. That drill was drilling bigger than the required size. He changed his drill size to 1 in 5/16, and the hole he drilled and just rechecked was drilling on size at this time. He will now proceed to drill to his proper depth, in this case, which is 3 inches. Drill. A little trick for many of you for correct depth. There are several ways to do it, and a good practice to use several of them at one time so that to ensure that you don't go too deep. What Gene did here was, first he set his depth on his quill with the spider and the spindle attachment. A second way is simply by measuring the length that the spindle is out from the machine. After you touch the tip of the drill to the job, measure the length that the spindle is out. After you reach depth, you can check the length that you obtained. Another thing you can do is mark your drill. And this is the other one that Gene used. He marked the drill for the correct depth. What he's now doing is putting a scale in a hole and checking to see if he does have the correct depth. We're on so he can start his taps easier. Remove his drill. Remove the arbor. Install the new arbor, the one that he's going to use for the tapping head. He also has this arbor match marked from his previous taps. He now installs his tapping head, which is also match marked with his arbor. The way he match marked everything was prior to tapping. He worked on a test piece, and he indicated their arbors, their tapping head, the arbor or sleeve for the drills. He indicated the drill, and he found out his best running condition of those adapters. He then match marked them to that location. And on each succeeding hole, he uses the arbor, tapping head, and drill in the same location each time. Gene's now installing what is known as the number 2 tap. In all drilling cases, we should use all 3 taps, the number 1, 2, and 3. Prior to this series here, we found out we cannot tap these holes with the number 1 tap. It has a tendency to pull in and ream the hole out. So we found our best performance was using the number 2 and the number 3 tap. In tapping, there are several ways to do it and several things that must be performed. One is good lubrication, which Gene is doing right now. A very good lubricant in the shop is what is commonly known as trim tab, and that's what he put on. A lot of us use easy foam. It works on smaller size taps, but it does not work too effectively on the larger taps. Another point is when running your tap in, which Gene is going to be doing shortly. There are 2 ways in horizontals that we apply pressure and make our tap work. Number 1, on most of the machines we use here, we use what is called the spider. Here we're looking at the spider. Simply by applying pressure to the spider, which will push your spindle out and put pressure on a tapping head, exerting pressure on the tap itself. The thing here is to apply a sufficient amount of pressure. In many cases, you might be pulling on that spider very hard to get the pressure that is needed. On this machine, we're more fortunate in that we can use a feed selection. On most of the other machines, there's only 1 tap feed that we can use, and that is 1/8 of an inch. The lead is .125, which is 1/8. You engage or set up your feed selector to 125 thousandths feet and engage your feed. Now on his 6-thread taps that Gene is doing, the lead is .166. This machine can be set to feed at .166, and that's what we're going to see Gene do right now. See here is a most unusual condition for a tap. Here you're looking at stringer chips. See where the pencil is. What he did was he ran in the 1.25 inches. He will now back off and hand tap, removing the tap so that he can remove the chips. What he's going to have to do here is go in an inch or so, back out, and clear the chips out. In any tapping, it's very important that we clear the chips, or they could be causes of reaming the hole, crossing the threads, and numerous problems could result. We'll now clear the hole, blowing air into it. Another problem that we might seem to have trouble in, we'll see Gene here. He's cleaning his tap off before he puts it back in again. He's applying more lubricant. Right here, hand start the tap again to get it back into the correct lead. Many times you have a tendency to put the tap right in the beginning of the hole. Go back to our spider, ram our tapping head out there and try to force it in here. What'll happen here is you'll ream the threads right out. So the hand start the tap as you see he did here. Applying the pressure with a spider, discharge it so that the tapping head engages. Now he will put pressure onto the tapping once again. See him tapping? Stop. He will back out once again. Just break the thread, he'll stop. He won't use machine power, he'll hand feed out. Using a wrench, he'll go and remove the tap. He will clear it out once again. He's tapping it out, engages the clutch, puts adequate pressure on, feeds again. His tap was properly marked to depth. We'll now back it off a little bit, stop, use his wrench, and remove it by hand. Now has his number 3 tap. What he's doing is applying lubricant. He will put it into the hole and he will feed the number 3 by hand as far as he can go. Get it in as far as he could go by hand. Now brought his spindle out once again. Engage his clutch. Brought it tight again, so he'll apply a pressure with his spider. He has his tap marked to the proper depth. Now checks it. Gotta go a little bit deeper. Backs it off and remove it by hand. Just to fit. If it was not required to have a 2B or a 3B fit, we'd simply power feed coming out with the taps. Because a good fit is required here, that is one of the reasons why we have to hand feed to remove the taps. It will help get the better fit. Now clear the hole out. You got to clear the hole out before you use your gauges to check the threads. What he's going to do now, he's preparing to use his go gauge. He's going to enter the hole and check it for fit. When using the go gauge, and for the 2B fit, he's checking it for wobble. If he would be getting a lot of wobble or shaking the thread, he enters. It could be, if you get a lot of wobble when using the go gauge, it could be caused by run out from your drill, from your tapping head, from the arbor that your tapping head's in. What he'll do is run it to the bottom of the hole, mark the go gauge, and then measure it to assure that he has the proper depth in the hole. And also assure that he has the proper fit. The go gauge tells you if you have the proper root diameter. The no-go gauge, if it would enter too deep, would tell you that the bore that you have is too deep. Simple way to remember, if the no-go goes too deep, the bore or the hole that you drilled was too big. And earlier in the film I mentioned that he did have to change his drill size because he was getting too big of a hole. Now trying his no-go gauge. Does not enter. He's in good shape. He's got a good hole. The big thing to remember in drilling and tapping, in most cases, do not use the power feed. This machine is one of the few machines that you can use the power feed with the lead of your thread. Do not use feed. Second, make sure you have enough pressure applied to the spider. In other words, enough pressure onto that spider, creating pressure onto the tapping head and onto the drill as it enters the hole. Third, clear out those chips from the hole. Chips in the hole will give you all kind of problems. It demands a good fit and feed when removing the taps.
Man, route 2 stall. Crane and chain man, route 2 stall.
Do you have anything you might want to add?
Well, just that you should be very careful with your chips and make sure your hole is cleaned out. All your chips are cleaned out and you're cutting with no chips binding on the tap.
Okay, thank you, Gene. Good job.
You're welcome.
manufacturing complex in the Bethlehem Steel Corporation. It is 4 stories high and covers over 10 acres of floor space. The length of the shop is approximately 1/3 of a mile. In years past, this facility employed over 500 personnel. Today, total employment is in the neighborhood of 250, plus a multitude of staff and service groups.